Esme Liao.
I'm Ryan Zhao.
And I'm Elizabeth Isaac, and we are Poolesville Cares.
Throughout the past 6 months, we've had the wonderful opportunity to work with the Hydrocephalus Association, and Mike, a member in the community with hydrocephalus who works as a security guard. Here's a word from our client about the organization and its mission.
My name is Amanda Garzon, and I am the Chief Operating Officer at the Hydrocephalus Association. The Hydrocephalus Association is the national nonprofit whose mission is to find a cure for hydrocephalus and improve the lives of those impacted by the condition. Hydrocephalus is an abnormal accumulation of fluid in the brain. 70 to 80% of people who have spina bifida actually have hydrocephalus. But you can also develop it from a brain injury. You can also develop it from a brain tumor or from a brain infection. And there's also a form of hydrocephalus that develops in seniors.
In order to combat the balance and depth perception issues, we had the idea to design a smart cane that could switch between a traditional walking cane and a seeing cane for the blind. This is more convenient and cost-effective for the user, as it only requires them to purchase and carry one device. We also wanted some type of sensor that could inform users of any obstacles around them.
Our initial idea utilized PVC pipes and elbow fittings in order to create the traditional shape of a cane. We would have a small PVC pipe inside a large PVC pipe, along with a wooden dowel to act as a hard stop in order for the user to adjust the height of the cane.
We originally planned on using a pen mechanism to retract the rolling tip. However, as you can see in the following video, the range of motion was way too small. In light of this, we decided to switch to a rack and pinion mechanism powered by a stepper motor. However, after 3D printing and testing this mechanism, we realized the stepper motor we were using had very little stall torque and could not effectively move the rack. We then decided to switch to a servo motor and printed a new rack that meshed better with the pinion.
The final cane design has holes in 1-inch increments that allow the user to change the height of the cane to their preference, ranging from 3 feet to 5 feet. The 2 buttons on the side extend the rolling tip up and down depending on the needs of the user.
While using the cane, the ultrasonic sensor is able to detect obstacles within 4 inches, causing the piezo to buzz whenever there's an obstacle in the way, assisting with depth perception issues. We tested our ultrasonic sensor and piezo by setting a threshold distance to be detected by the sensor for the piezo to buzz. Our first set of trials had the threshold set at 10 centimeters, with all the 10 succeeding. Our second was set to a threshold of 50 centimeters, where 8 of the 10 trials passed, and our third set was set to 100 centimeters, where 9 of the 10 trials passed.
We tested the effectiveness of the cane on balance issues by setting up a straight line for participants to walk across. We then had them spin 5 times and attempt to walk across with and without the cane. The average distance deviated from the line without the cane was 1.275 feet, and with the cane was 0.325 feet. To measure the weight capacity of the cane, we placed it on a scale and pushed down on it. We deemed the weight capacity to be at least 140 pounds because that was the most force that we were able to exert on it. However, we observed that it is capable of taking more weight, and so we concluded the test to be satisfactory.
Walking is something that most of us take for granted as we can easily do it every day. However, there are some people who must take every step carefully. We believe that with our device, we'll be able to give people affected with hydrocephalus, as well as any other person who has difficulties balancing, reassurance in their safety, and help them effectively navigate any surroundings that they come across.
We would like to thank the Hydrocephalus Association for working with us throughout the project and giving us the opportunity to help those with balance and depth perception issues.
We would also like to thank Amanda, Sierra, and Mike for their valuable feedback and continuous support. Finally, we would like to thank our supervisor, Mr. Lee, for the continued guidance and resources that made this entire project possible.